In this problem, a ball is being thrown horizontally at a point 44.4 meters above the ground. So throwing a ball off a cliff, it travels a distance of 39 meters before it strikes the ground. What was the initial speed? So if we draw a diagram, we're taking this ball, we're tossing it straight out here. We want to know this initial speed. What the ball does is, travel down here, hit the ground with a distance of 36 meters, while it fell a distance of 44.4 meters. So just how fast was the ball going in the first place to travel these 36 meters? Well, to figure that out, we know that we're going to have an acceleration due to gravity of 9.8 meters per second squared, that the original y velocity would equal 0. This ball is not falling until we let go of it. So really here, when we say we're solving for this original speed, we're really solving for the x, or the horizontal portion of its speed. And what I need to know is, well, if I just drop this ball off the cliff, how much time would it take for the ball, not for us, how much time would it take the ball to fall 44.4 meters? And so when we think about displacement equals original velocity times time plus at squared over 2. Well, we know the ball's gonna fall 44.4 meters. So instead of an x, I'm gonna use a y because we're on the vertical axis. But that original y velocity was 0. So that part of the equation equals 0. We're talking about acceleration due to gravity, so I'm going to replace a with a g. And then when I get time on its side by itself, I'm going to multiply by 2. I'm going to divide by g and take the square root of both sides. So this time will equal 2 times the 44.4 meters divided by 9.8 meters per second squared. And I'm going to take the square root. So 2 times 44.4 divided by 9.8. Take the square root of that. I get a time of 3.01 seconds. All right, so it takes this ball 3.1 seconds to fall straight down. Well, it also takes it 3.1 seconds to go horizontally 36 meters. So if we want to find the speed on the x-axis, it's going to be that distance it traveled divided by the time. So 36 meters divided by 3.01 seconds. We get 11.96, so you can round it up to 12 meters per second.